Okay, these are Julie's notes, which she's taken a photo of and sent to me. So thank you, Julie. This is exercise 4.4 from the Year 10 textbook, chapter 4. So it's exercise 4.4. In this exercise, we look at deductive proofs involving angles. Now, what's special about this exercise is that you have no values, okay? So there are no values indicated, yet you have to prove a number of things. So in this particular first question, question 2, we're told that CB is perpendicular to AB. So here we can see this right angle between CB and AB. We're also told that DB, this line or interval here, is perpendicular to BE. So we've got another right angle just there. So angle DBE is a right angle and angle CBA is a right angle. And we're asked to prove that angle ABD, which is this angle in here, is equal to angle EBC. And then in part B, we're asked to prove that this angle ABE plus angle DBC, so the big angle there and this small one in here, DBC, that when you add them together that you get 180. Okay, notice again, we don't have any values. So what we do, because we have to prove that angle ABD, so this angle in here, equals angle EBC, it's best to let angle ABD equal X. So we put that in there. So you need to write an X here in this diagram. I'll just fix that up now. And we've let angle ABD equal X, and I've put a little X there in red. So because this angle here is X, we know that this angle here, this angle DBC and this angle ABD, that the two of those angles add up to 90 degrees. So we can write angle DBC plus angle ABD equals 90 degrees, reason that they are complementary angles or angle sum of a right angle. Now we don't know what DBC is, but we know that ABD is X, so we go angle DBC plus X is 90, taking this X over to the other side, we get that angle DBC is equal to 90 minus X. So you can write that in on your diagram as well. So as you work something out and label an angle some way, you should then write the size of the angle in the space, okay? Now, we know that we've also got a right angle here, that angle DBE is a right angle. So if this is 90 minus X, then this angle over here will also be X. So I'll just put that in and let's just write that up now. So we've got, again, so we've finished that angle DBC is 90 minus X. Now, we know that angle EBC plus angle DBC, so I'll just move this away at the moment. So angle EBC, this one, plus angle DBC, this one, is 90. Again, angle sum of right angle. Now substituting in the values that we know, so angle EBC, this one over here, is equal to 90 minus whatever angle DBC is. Now we know that that's 90 minus X, because angle DBC is 90 minus X. So if we open the bracket there, we get 90 minus 90 plus X, which equals X. Now that's a pretty long way of working it out, but you can see that we've got these X 90 minus X combination and another X 90 minus X combination. So an X and a 90 minus X adds up to 90, and an X and a 90 minus X here adds up to 90. Now we don't know the value of X, so therefore we've just proven that angle ABD, this one here, is equal to angle EBC, which is equal to X. Now, for example, X could have different values. If X was 40, for example, this would be 40, that would be 90 minus 40, which is 50, and this would be 40 as well. But we do not know the value of X. Now, in part B, you have to prove that angle ABE, which is the really big one, plus angle DBC, which is this one in here, is equal to 180. Now we know that angle ABE, I mean, we can do this 3 or 4 different ways, but we know that angle ABE is made of this right angle ABC plus this angle here CBE. So we say angle ABE plus angle DBC is equal to angle ABC plus angle CBE, that's what ABE is, plus angle DBC. We then replace what the size of all of these angles. Now we know that angle ABC is a right angle, and we know that angle CBE is X, so we put that in. and we know that angle DBC, so DBC is 90 minus x, so we substitute that in as well. And when we add all of this together, we get 90 plus x plus 90 minus x. Well, 90 plus 90 is 180, and x minus x is 0, so our answer is 180. So we've just proven what we've been asked to prove there in question 2. Exercise 4.4, question 3, another example. Now these x and 180 minus x aren't initially on the diagram, so please do not write those up. Your diagram, I'll just cover them at the moment, won't be a minute. Again, this is exercise 4.4, question 3. Now in this question, I've got these bits that are highlighted here in a dark grey. I don't want those bits highlighted in a dark grey written down yet. So if you go to your textbook, you'll see that question 3 just has the diagram without the x and these 180 minus x's. So the question says that PQ, okay, reading this, PQ is a straight line through O. So PQ is a straight line through O. We're told that PO bisects angle ROS. And we're asked to prove that angle ROQ is equal to angle SOQ. Now, the original diagram does not have any of these x's and 180 minus x's, so please pretend that they are not there. You can actually just go to your textbook and see what is there, okay? So, because we've been given information about these two angles that PO bisects angle ROS, your first step would be to let angle ROP, this one here, equal x. So let our angle ROP equal x. Therefore, because that's x, we can now write that this is x. So now we write this x in here, and we say, well, angle POS is equal to angle ROP, which equals x, and the reason for this is that PO bisects angle ROS. Now we know that we've got a straight line here, so therefore angle ROQ, this one here, will just be 180 minus that angle there. So angle ROQ is 180 minus angle POR. The reason for that is that they are supplementary angles, or you can write angle sum of straight line. Therefore ROQ is 180 minus whatever angle POR is. Now POR is x, so it's 180 minus x. Now we can do the same thing down here. Angle SOQ is equal to 180 minus angle POS. Similarly, meaning it's the exact same reason as the line above. So therefore angle SOQ is again 180 minus whatever angle POS is, which is x. So therefore we can now say there should be an angle symbol here, girls, so put an angle symbol in. So therefore angle ROQ is equal to angle SOQ, which is equal to 180 minus x. So now we've just proven that angle ROQ is equal to angle SOQ. We're now going to go to the next question. Exercise 4.4, question 6. Now in this diagram you are not given this blue line, so please do not put that in. You're just given this shape A, B, C, D, E. Please go to your textbook and have a look at the diagram that's in there. So you're told that BA is parallel to DE, and you are given this shape here in black, and that these two lines up here are parallel. The question says to prove that angle BCD, so this big angle in here, is equal to this angle ABC, is equal to this angle in here, plus angle CDE, this angle in there. So the first step in your proof is to construct another line. See, when you've got parallel lines, you really need a transversal passing through them. So what we're going to do, if we put another third parallel line here between the other two, we can see that BC is a transversal between the top and the middle parallel line, and that CD is a transversal between the parallel lines FG and DE. So, first step, construct FG parallel to AB and DE and making sure that it's passing through C. First step, because you're asked to prove that this bigger angle here, that angle BCD equals angle ABC plus angle CDE, what we'll need to do, because these two are the smaller ones obviously, we're going to let angle ABC equal a pronumeral and we're going to call it x. So we're going to say, right, let angle ABC equal x. So mark that in on your diagram. And the thing is, we're going to let this angle down here equal something as well, but we don't know whether it's the same size as the angle up there, so it needs to be given another pronumeral. So what we're going to say is let angle CDE equal y. Now that we've got some parallel lines up here, we can see we've got a backward Z here, so we've got alternate angles. So we can say, well, angle ABC plus angle BCF, they form the Z. Sorry, not plus BCF. We can say angle ABC is equal to angle BCF, which equals X. Reason, alternate angles, and AB is parallel to FG. I don't want you just saying parallel lines because there are more than two pairs of parallel lines here, and you need to specify exactly which lines you're talking about. Now similarly, we've got a Z happening here as well with the parallel lines. So we can say that angle CDE, this one down here, is equal to angle FCD, which equals Y. Reason again, alternate angles. Instead of just saying parallel lines, we're going to say that FG is parallel to DE. Remembering the parallel lines that you choose have to be the two parallel lines that form the Z. Okay? Now, we know that angle BCD, this one here, we can clearly see is X plus Y. But angle BCD, this angle here, is made up of two parts. It's made up of angle BCF plus angle FCD. So we've written that there, which is equal to X plus Y, because that's what they are, and that happens to be equal to angle ABC plus CDE, because X is actually equal to angle ABC, and Y is actually equal to angle CDE. So that's the end of question 6. This is question 4 from exercise 4.4. We are told that AC is a straight line through the point B. We're also told that DB, this line DB, bisects angle ABE. And we're also told, so in the question none of these markings are on the diagram, so please just put the line ABC there, put DB, EB and FB, but all of these bits in blue are actually not on the original diagram, so please don't put the rest on there. So please look at your textbook to see what question 4 looks like. So again, we're told that DB bisects angle ABE, meaning that that angle in there and this one here are the same. And we're also told that FB bisects angle EBC. So this angle in here is equal to that angle there. And what you have to do is prove that DB is perpendicular to BF. So you have to prove that this is a right angle. Now I know that there's a right angle symbol drawn here, but this is being drawn after the question was done. So let's pretend that none of these blue symbols are there, and we've just got this blank diagram with the bits in black. The first part of the proof is to let one of the angles be X. Now, because we know that DB bisects angle ABE, we're going to let one of those angles here equal X. So let's let angle ABD equal X. Now, because we know that DB bisects angle ABE, we can say, well, therefore, angle DBE, which is this one up here, is equal to angle ABD, which equals X. Reason, DB bisects angle ABE. Now we're going to do the same thing over here. Now the thing is, we do not know if these are both X. They do look a different size, and they more than likely are a different size. So what we're going to do is we're going to let this angle down here equal Y. So let angle FBC equal Y. Because we know that FB bisects angle EBC, we can say, well, angle angle EBF is equal to angle FBC, which is equal to Y. Reason, FB bisects angle EBC. So we've got X and X and Y and Y. And the thing here is that we know that the X and the X and the Y add up to 180, because this angle ABC, and it is an angle because B is the vertex of an angle of that angle. So the reason that they add up to 180 is an angle sum of straight line ABC. Now here we've got X plus Y plus Y is 180. We know that X plus X is 2X and that Y plus Y is 2Y, and we get that they're 180. So we can see here we can factorize out 2 as a common factor. So we go 2 bracket X plus Y is 180. We can clearly see that X plus Y, see 2 times 90 is 180. So therefore X plus Y is 90. Okay, that was the end of that lesson on exercise 4.4. And for homework, You need to copy out example 1 and 2, which are at the beginning of exercise 4.4, and you have been asked to do exercise 4.4, question 1, 5, 7, 8 and 9. Okay, from memory, the girls were also asked to look at Bethlehem Online at the Year 10 5.3 page, and you are also to copy. No, actually that was it. That's tomorrow's homework I'm talking about. So that's it for homework at the moment. The next video, I'm actually going to continue this video, which is the homework problems for exercise 4.4. But please attempt this first before you watch the rest of this video.